So, welcome back, friends. This is session 16 on checking and fixing database consistency if there are any problems. So, checking database consistency, as we know, in SQL Server also we have a similar utility. Here also we have a utility, okay, which can be used to check the inconsistencies or problems in the database and tables, and we can fix that using this. So the database consistency checker, which stands for DBCC, okay, it provides commands for yes, database consistency checker provide commands for checking the logical and physical consistency of a database. It can be used to check the page linkage and the data pointers at both the page level and the row level. Bami, can you put off your mic, please? Thanks. So, page linkage and data pointer, it checks page linkage and data pointers, which I'll discuss in next few slides, at both page level and row level using check storage and checktable and checkdb. The page allocation, it also checks the page allocation using check storage, check allocation, check verify, table allocation, text allocation, and index allocation. So that means it can check various type of storage and consistency inconsistencies in the database using this various commands which are available through DBCC. As I said, this is a utility in itself, DBCC consistency checker. Okay, for consistency within the system tables in a database can also be done, can also be checked using DBCC with a command called checkcatalog. So DBCC is used with these commands like DBCC check storage, DBCC check table, DBCC check DB, DBCC check allocation, checkalloc, DBCC check verify, and so on and so forth. DBCC check storage stores the result of checks in the DBCC DB database. By default, this database is not present. You have to build it, you have to configure it, and you have to set up this DBCC database. So you may not get it right now on your system, on your machine. You have to configure it. Okay, so first is you have to assign the storage, you have to assign the logs, you have to assign, and you have to execute a Redis script which is available for this purpose, and you have to configure various options, and then only you will be able to use DBCC. So first you need is dbccdb, because dbccdb is basically used to store the output and store the details about the dbcc command. Okay, you can print reports from dbccdb using the dbcc stored procedures which are available. A lot of stored procedures are available. Usage of dbcc commands: a part of the regular database maintenance. The integrity of the internal structure of the database depends upon the system administrator or the database owner running database consistency checks on a regular basis. So it is the responsibility of the DBA, it is the responsibility of the administrator or the database owner to run this command on a regular basis. To determine the extent of possible damage after a system error has occurred, can be used, you can use the DBCC commands. We can use the DBCC commands before backing up a database or for additional confidence in the integrity of the backup. So basically, to check any inconsistency or consistency issue in the database or table or pages or memory or storage, we can use DBCC related commands. If you suspect that a database is damaged, for example, if you are using a particular table, generate the error message table corrupt, then you can use DBCC commands to fix that table. Like I remember MySQL has a command called checktable. Okay, same way in Oracle also we have commands to automatically at a different level. In fact, I would say there are some which will only check, there are only which will try check and try to recover. Okay, so there are various levels of commands in Oracle and SQL Server and MySQL, I remember. So here also we use DBCC commands for the same purpose, to come out of the problems. So now the little background on the allocation of pages, memory pages on the Sybase DB, this ASE. When you initialize a database device, what exactly happens? What happens is the disk init command divides the new space into allocation units. Oracle, I remember we call them as segments. Okay, here also we have that allocation units. The size of allocation unit depend on the size of the logical pages your server use. Maybe 2, 4, 8 or 16K. The first page of each allocation unit is an allocation page which tracks the use of all pages in that allocation unit. Allocation pages have an object ID of 99. They are not real database objects and do not appear in the system tables. But DBCC errors on the allocation pages report this value. That means there are certain things which are not reported and not stored in the databases, but DBCC can check them and report the errors and report the issues on them also. Details about them also. That is allocation pages. The pages and object allocation process, how it works actually. When a table of an indexed partition requires space, the SAP ASE allocates a block of 8 pages to the object. This 8-page block is called extent. Each allocation unit contains 32 extents. The size of extent also depends on the size of server logical pages. SAP ASE uses extents as unit of space management to allocate and deallocate space as follows. First, when you create a table of an index partition, the ASE allocates an extent for that object. When you add rows to an existing table and the existing pages are full, then SAP ASE allocates another page. If all pages in an extent are full, SAP allocates an additional extent. When you drop a table of an extent partition, SAP ASE deallocates the extent it occupied. When you delete rows from a table, so it shrinks by a page by deleting that row, then SAP ASE deallocates the page. If the table shrink off the extent, SAP ASE will deallocate the extent itself. Every time space is allocated or deallocated on an extent, SAP ASE records the event on allocation page that tracks the extent for that object. So this is how it works. Look at this allocation. The figure shows that data page is set up within extents and allocation units in the SAP ASE. So here what we have is, this is 1, this dotted line and indicate this is extent 0. The second line is extent 1, extent 2. So this is one entire allocation unit of 256 pages. This one particular thing, this is called allocation page. So there are 7, 0 to 7, 8 allocation pages in this extent 0. So allocation, so extent 0 has 8 pages. So total 256 pages are there in this one allocation unit. Okay. And this is again another example. This is extent number 280. So each extent have 8 pages, allocation pages, and each allocation unit have 256 pages. Alright, this is how it works. 256 pages means total multiplied, extent multiplied by number of pages. So it is pure mathematics. Okay, this is how the space or memory is managed. DBCC check allocation checks all allocation pages, page 0 and all the pages divisible by 256 in a database and reports on the information it finds. DBCC index allocate and DBCC tablealloc checks for the allocation of specific database objects like index or table. Object allocation map, that OAM. Each table and index has an OAM. The OAM is stored on pages allocated to a table or index, and it checked when a new page is needed for the table or index. The OAM pages points to the allocation pages for each allocation unit where the object uses the space. The allocation pages tracks information about extent and page uses within the allocation unit. The OAM is stored on the first page of the first segment and points to the allocation pages. The allocation pages track the pages used in each extent by all objects with the storage space in that allocation unit. So this is how memory is managed. So example of object allocation map. The number of entries per OAM page also depends on the logical page size and the server is logical page size the server is using. The following table describes the number of OAM entry for each logical page size. Now, for example, if you are using 2 kilobyte of logical page size, then you will have 250 OAM. If you have 4K, then 506. If 8K, 1018. And if you are using 16K logical page size, you will find 2042. The OAM pages points to allocation pages. I have something similar example, if not same. I'll not say that it is same, but I would like to, if you know this, that inode table in Unix. It is all about how the addressing is done and how the tracks of addresses are managed and where these addresses are stored. I remember, if not exactly same, but on the similar line, I remember the inode table has 12 fields, out of which 4 fields are reserved for the addresses of the data of the file, and these 4 fields are direct, indirect, single indirect, double indirects, that way, and which has one block is reserved for the addresses. Now if I'm using single indirect, then it's a pointer. So we have a concept of pointers and pointing to the memory where the actual data is located. So it is how many size. If you are say using 4 kilobyte size, we need 506 entries. Okay, so number of entries depends on the logical page size. So basically the what we need is we need to address the entire memory location. So if we have 4 kilobyte logical page size, we need 506 entries to address the entire memory, logical page. The allocation pages in turn track the information about extent and pages uses within the allocation unit. In other words, if the title table is stored on extent number 24 and 272, the OAM page for the title table point to page 0 and page number 256. So it will track entire range within that allocation unit. Page linkage is a kind of pointer table, that linked list. After a page has been allocated to a table of an indexed partition, it is linked with other pages that are used for the same object. Each page contains a header that includes a number of pages that precedes its previous and the page that it follows next. That means it's a double linked list. What was the previous page? What is the next page? Where a new page is allocated, the header information on the surrounding pages changes to point to that page. It is as simple as that. Again, double linked list. DBCC checktable and DBCC checkdb check pages linkage. DBCC check allocation and DBCC alloc and DBCC indexalloc compare page linkage to information on the allocation pages. So in a way, it will if there's something missing, it will try to rebuild that also. And this is, as I said, no, this is one link. So this is one page, previous and next. So we have, these are the existing pages. So new link and old link. So you can see that if we have, this is first node and this is the second node. If I want to insert one node in between, so old link will be removed, and it is something like inserting a node in a double linked list. That's it. Okay, it's a simple linked list, my friends, and managing the pointers and using pointers to manage the links. DBCC checks. The DBCC command that you can run depend on your role. For example, only the table owner can execute DBCC with a checktable, fix text, reindex keywords. Only the database owner can use checkstorage, checkdb, checkcatalog, checkallocation, indexalloc, and textalloc, and tablealloc keywords. Only the system administrator can use db repair keyword. So it can fix the errors also using db repair, checkcatalog. Let's understand one by one, few of them, not all. DBCC checktable checks the following: data pages and index pages are properly linked, making sure previous page, current page, and next page are consistent throughout the page linkage. Index are sorted properly in the correct order. Consistency of all pointers, making sure that index pointers to the page and row are still valid. Data rows on each page have entries in an object allocation map, that is OAM page, and they match their respective locations on the page. Update the information on OAM page that potentially can become inaccurate. If the data rows are not occupied for in the first OAM page for an object, DBCC checktable updates the number of rows on that page. Syntax is an example of checktable catalog. DBCC check catalog, DB name, fix all or fix all. Now if you say DB name, which no database name, current database will be used if you don't provide any database name. Fix means fix the following errors. These are the error codes which are written. So if you are getting these errors, now again learning the errors, remembering the error code is not required. But then definitely when you are actually stuck, you will be forced to learn these error code, and you will be forced to find out what command is that which can fix these errors. So if you are getting error number 15049, 15050, 5152 and 53, these errors can result from consistency check for the sys indexes command. So system tables are not included in the checks when fix is used. So all means include system tables for the new inconsistency check, check consistency only, no fix. And fix all means include system tables and fix common errors, or fix all of them. So if we say fix, it will not fix and check system tables. If you say all, it will check all but not fix. And if you say fix all, means it will do all. So this is a check catalog. DBCC check storage. In order to run DBCC check storage, we need to install DBCC database. It is a special DBCC command that combines the functionality of all the commands. So the check storage, you can say, is a mother of all commands. DBCC checktable, it combines the functionality of DBCC checktable, checkdb, checkalloc, indexalloc, and tablealloc. That is why people recommend, okay, you learn DBCC check storage, you understand DBCC check storage, you would not want anything else. You will not require anything else. So check storage is overall the overall command of all these commands. The DBCC check storage, in checktable it only checks for databases. Checkdb, it checks for the databases. DBCC check storage just generate a report and does not fix the error. When DBCC check storage command is run on a DB, it puts that DB in dbccdb and perform all other DBCC commands. The faults that encountered in the DBCC check storage will be stored into the DBCC faults table. Whenever DBCC commands are run on user databases, first DBCC needs to be installed, and this database can be on production server or development. You have to decide the location of the database. The advantage of using DBCC check storage, it does not lock tables or pages for extended period of time. Advantage is it executes in parallel using multiple worker process, but then you need to configure that worker processes, which you will learn in the lab assignment, how to configure multiple worker processes. I am discussing only the concepts in this, and lab assignment will be actually walkthrough of the DBCC check storage and the other DBCC commands. The advantage is that log integrity faults in the database instead of standard output. So best thing is that you can it will log the faults in the table in the DBCC database. It scales nearly linearly as resources are added. DBCC check storage checks the entire database including unused pages. It stores, the advantage of DBCC check storage is also that it stores check storage activity and results in the DBCC database, so that you can generate reports later on. A check storage only detects the faults, it will not repair. We need to run appropriate DBCC command to repair the faults. So basically what you should do is you should schedule it on a regular basis, and you can write a very good script based on the output of the results. So if you write a good script which will run the command periodically, and checks the data stored in the DBCC table, DBCCDB database, so you can generate reports, and you can you can automate the entire process. That's a good thing. And you can be proactive in taking decisions, because ultimately it will generate warnings also, it will generate information pages also. So that will be very helpful in taking proactive decision, taking decision before something goes wrong. A scan workspace within which contains a row for each page of the target database, and a text namespace contains a row of each table in the target database that contains the text or image column. So we can it will actually scan, it will check the images and text also if they are stored in the field, any field of that. DBCC check storage is different from other commands of DBCC. Why? Because the DBCC database to store configuration information and the results of checks made on the target database. So because this is the only command where the results are stored in the database. However, you can run DBCC check storage from any database. Okay, at least two workspaces to use during the check operation. So you have to configure these two workspaces. Okay, system and stored procedure to help you prepare your system to use DBCC check storage and to generate reports on the data stored in DBCCDB. Steps in DBCC check storage operation. What exactly happened and how it works? First step, inspection. It uses the device allocation and segment definition of the database being checked, and the max worker processing and named cache configuration parameters to determine the level of parallel processing that can be used. Second step, planning. DBCC check storage generate a plan for executing the operation that takes advantage of parallelism discovered in step 1. Third step, execution and optimization. It uses adaptive server worker processes to perform parallel checking and storage analysis of the target database. It attempts to equalize the work performed by each worker process and consolidate the work of underutilized worker processes. As the check operation proceeds, it extends and adjusts the plan generated in step 2. And final step, last step, is reporting and control. During the check operation, it records in the DBCC database all faults it finds in the target database for later reporting and evaluation. It also records the result of its storage analysis in the DBCC database. So this is a very good utility, my friends. Example is simple. First is DBCC trace on go, DBCC check storage pubs3, pubs2. You can do that, but then you cannot try these commands unless you build the DBCC database and create the DBCC database. Thank you so much for watching. This completes the session number 16.